my dear lovely viewers, welcome to another fascinating math video. In this tutorial, we have another interesting problem to tackle. It's actually on logarithmic equation. Let's take a look at it. So we have here this aesthetic logarithmic equation from Indian Olympiad prep. So we have s upon 3 whole raised to the power of 3 plus log x equal to 3 into 10 to the fourth. So as you can see here, the logarithm here does not have a base. That implies that it is in base 10. But to solve this problem, we are still going to take the log to base 10 on both sides. I shall do that. So we have log to base 10. I'm not going to write it. S upon 3 whole power 3 plus log x equal to log of 3 times 10 to the fourth. Okay. Have we done this? The next thing is to use some of the fundamental theorems in logarithm. We know that if we have the log to the base of, say, a, of the quantity a, of the argument b multiplied c, we can actually write this to be log to the base of a of the argument b plus log to the base of a of the argument c. So this is the multiplication slash the addition law of logarithm. So if we also have log to the base of a of the argument b upon c, we can also split this to be log to the base of a of the argument b minus log to the base of a of the argument c. So if you call this division slash the subtraction law of logarithm, you're also very correct. So now, we also know if the argument of a log is raised to an exponent. If I have the log to the base of a of the argument b raised to the exponent c, the exponent can actually find its way to the back of the log, becoming a coefficient. So I can write this to be c log to the base a of the argument b. So with these theorems, I can now refine this problem. Now, I'll first use the power rule here, which is what we have. This is the power rule of logarithm. If I use the power rule, it means that the exponent here, 3 plus log of the argument x, is going to come to the back. I'll write this imply 3 plus log of x, which is log to the base 10 of x, then log of the argument s upon 3. Let me put this in parentheses, equal to, on the right side, I will take log to the base 10 of the argument 3 plus log to the base 10 of the argument 10 to the fourth. Okay? So this is interesting, right? So we use the division rule here. We use the power rule here. So this is going to give us 3 plus log to the argument of x. I'll put this in parentheses. Log of x minus log of 3 equal to, now here we have log of 3. Here, log to base 10 of the argument 10 to the fourth. Before we come to the back, we have log to base 10 of the argument 10, which is 1. So 4 multiply 1, that will be 4. So the next thing I shall do is to actually distribute these two parentheses. So 3 multiply log x, that will be 3 log x. 3 multiply negative log 3, that will be negative 3 log 3. I'm done with using 3 to distribute. Log x multiply log x, that will be log s whole squared. Then log s multiply negative log 3, that will be negative log 3 log x. So everything equal to log of 3, then plus 4. So guys, so you can see that we are making headway. Now, Because of the log s squared here, I am suspecting the quadratic equation. So I will try to rearrange this equation starting with the highest power of log x, which is 2. So it's going to give me log s whole squared. Then I have negative log 3 log x here. Then I have 3 log x. I can actually bring them together. So I will have plus 3 log x, then minus log 3 log x. Okay. Then minus 3 log 3, as you can see here, minus 3 log 3 equal to log 3 plus 4 on the right. Please don't confuse these, they are not together. Log 3 and 4 are separate entities. So like I said, this is actually a quadratic, So I can take everything to the left. So I'm going to be having log x whole squared. I will try to factor out log x from these two terms here. That would then be 3 minus log 3, then log x. It's an interesting question, the best I've seen from India. Then if we move forward again, I will take log 3 to the right. No, sorry for the slip. I will take log 3 from the right to the left, and it becomes negative. And we already have negative 3 log 3. So that becomes negative 4 log 3. I'll take 4 to the left as well. That will be negative 4. Everything equals 0. Okay, it's pretty cool, right? So this is actually a quadratic equation in log x. So before I actually solve it using formula, I can refine this to be log x whole squared. Oh, there's a plus here. That's very sorry. There's supposed to be a plus here. Okay, I think I have to adjust this. This is plus 3 minus. Okay. 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 That was an oversight. Very sorry for that. So plus 3 minus log 3 log x minus 4. Then we have log 3 plus 1, everything equal to 0. So this quadratic equation is now in a standard form. So I can now say, okay, let k equals log of x. So I can then write this equation, this humongous equation, to be k squared plus 3 minus log 3 in parentheses k, then minus 4 into log 3 plus 1, everything equal to 0. So here our a is equal to 1, our b is equal to 3 minus log 3, then our c equal to negative 4 into log 3 plus 1. So if I use the quadratic formula, the value of k will be negative b plus or minus. I'll draw a very big square root sign. Okay, I've not substituted yet. Okay, everything upon 2a. So if I substitute the values of a, b, and c into this formula, we are going to be having k equal to, I'll take this negative outside, then put 3 minus log 3 in a parenthesis. I will draw a very big square root sign. Then I will take b and square it. That will be 3 minus log of 3 all squared minus 4ac. That will be minus 4 multiply 1 multiply minus 4 log 3 plus 1. That will be 16 multiply log 3 plus 1, okay, upon 2 multiply 1. So this is a very fantastic problem. So I will take this part of the board off and progress with the solution. I've always respected the Indians for their creativity when it comes to mathematics. Now, we'll do some cleanup. The cleanup is this: we should be able to take care of the radical. So I'm going to be having k equal to, I will try and use negative to open this parenthesis so that we can have some nice stuff there. So that will be log 3 minus 3. So it's better like this. Log 3 minus 3. What I've done here, folks, it's not a rocket science. Negative 1 multiply 3, that will be negative 3. Negative multiply negative, that will be positive. So I can put this in a parenthesis. I'll write plus or minus. Okay, I also omitted that here, plus or minus, just trying to manage this available space. Then I will draw a big square root again. 3 minus log 3 squared, that will be 9 minus 6 log 3. Okay, that will be 3 squared, which is 9. 3 multiply negative log 3, that will be negative 3 log 3. Then negative log 3 multiply 3, that will be another negative 3 log 3, which will give us negative 6 log 3. Then negative log 3 squared, that will become positive log 3 whole squared. Okay, we are trying to manage the space here. Okay, then we are having 16 multiply log 3 plus 1. Okay, plus 1. So everything divided by 2. The next thing is to clean up the radicands. So I'll then say k is equal to log 3 minus 3. Put this in parentheses, plus or minus. I will draw another very big square root. I'm trying to collect the like terms here. This is log 3 whole squared, log 3 whole squared. Okay, then okay, plus 9 minus 6 log 3. If I use 16 to open this parenthesis, that will be 16 log 3 plus 16. So upon 2. So we will collect the like terms inside the radical sign. So we have here log 3 minus 3 plus or minus. I will still draw a very big square root sign. We are going to be having log 3 whole squared. Then minus 6 log 3 plus 16 log 3. That will be 10 log 3. 10 log 3. 9 plus 16, that will be 25. Okay, I'm seeing something, all divided by 2. Okay, guys, we've done very well. We cannot say the problem is complicated. Our mandate is to simplify it for better understanding. So if you take a look at the quadratics inside this radical sign, 25 is a square number, which is 5 squared. So anytime you have a square plus 2ab plus b squared, this can be written as a plus b whole squared. So I can actually write the radicand, okay, that's correct, radicand. It's not only one person. The radicand here, I'll write log 3 whole square plus 10 log 3 plus 5 squared. So because there's a square here and there's a square here, and if I take log 3 multiply 5, that will be 5 log 3 multiply 2, that will be 10 log 3. So this entire expression is actually log 3 plus 5 whole squared. So I will take this off just for clarity. So I can then write k equal to log 3 minus 3 plus or minus. Inside this radical, I'm going to be having log 3 plus log, okay, plus 5. Sorry for the oversight. Plus 5 whole squared. So this is the killer punch. All over 2. So the square here, we undo the square root. We are going to be left with k equal to log 3 minus 3 plus or minus log 3 plus 5 all divided by 2. Then I will come this way. It's a nice problem, but regardless, we shall take care of it. So let's try and bring out the two answers. This is a quadratics because of the plus or minus here. We are going to be having two answers. I will say the first answer should be k equal to log 3 minus 3 plus log 3 plus 5 all over 2, or, okay, number, let's use a capital letter there, or k equal to log 3 minus 3 minus log 3 plus 5 all over 2. So if we try to collect like terms here, okay, it's going to give us log 3 plus log 3. So the first value for k will be 2 log 3. Okay, log 3 plus log 3, that will be 2 log 3. Then minus 3 plus 5, that will be plus 2 all over 2. Then the second value will be log 3. Okay, I think I can bring that down for the sake of our audience in high school. More like this is k1, okay? Then k2, I can call this one k1, this one k2. So k2 will then be log 3 minus 3. If I use negative to open this parenthesis, I'll be having log or negative log 3, then negative 5 all over 2. So k1 is going to simplify to be, if I use 2 to divide, I can actually factor it out. So you can see that the numerator becomes log 3 plus 1. So 2 divide 2, 1, then 2 divide 2. Then k2 is going to be log 3 minus log 3. That's going to be 0 to leave the system. Then minus 3 minus 5, that will be minus 8. Minus 8 all over 2, which is equal to minus 4. And recall that we made an algebraic substitution that k equal to log to the base 10 of x. I said that earlier on, that if the base of a logarithm is not written, it means that the log is to base 10. So I will say when k equal to log 3 plus 1, I can write log 3 plus 1 equal to log to base 10 of the argument x. Then, if I try to take care of that, I will transform that log equation into its exponential version. Then our homecoming is guaranteed. Okay, I can write this to be log to the base of 10 of the argument x equal to log 3 plus 1. To transform this to exponent or exponential equation, I will say s equal to 10 to the power of log 3 plus 1. I can use the multiplication law of exponent to simplify this. This is going to be 10 log to the base 10 of 3 multiply 10 to the power of 1. Now, log to base 10, we cancel out 10. We are going to be having 3 times 10, which is 30. So that's the first solution for K. Again, when K, okay, I should have been, okay, also, again, it's not the appropriate English to use it. Also, when K equal to negative 4, okay, negative 4, I also have log to the base of 10 of the argument x equal to negative 4. If I transform this to exponent, that becomes x equal to 10 to the negative 4th. So this is the second value for K. No, for X. I'm very sorry for that oversight. So the question is, can we test the validity of these two solutions? We can. I said don't check for this, but because of the peculiarity of this Indian math Olympiad prep, I shall test. I will recall that the original problem is s upon 3 to the power of 3 plus log x equal to 3 times 10 to the 4th. Now let's take the value of s equal to 30. So if s is equal to 30, we're going to be having 30 all over 3 to the power of 3 plus log to the base of 10 of the argument 30. Okay. So I can simplify this to be, now, 30 divided by 3, that's 10. That will be 10 to the power of 3 plus log to the base of 10 of the argument 30. If I use the, product rule of exponent here, I can actually split this to be 10 to the power of 3 multiply 10 to the power of log to base 10 of the argument 30. Okay? Log to base 10 and 10 will cancel out. Okay? Then we are going to be having, okay, we are going to be having 1,000 times 30, which is actually 30,000, which is 3 times 10 to the 4th. So the first solution for x, which is 30, is actually very correct. That's valid. Secondly, we also test for the second solution. And that second solution says that s is equal to 10 to the power of negative 4. So I'll be having 10 to the power of negative 4 upon 3 raised to the power of 3 plus log to the base of 10 of 10 to the negative 4th. Okay? Okay? Log to the base of 10 of 10 to the negative 4th. So this one can be written as, I will just leave this guy first. That will be 10 to the negative 4th all over 3. Then here we have log to the base of 10 of the argument 10 to the negative 4th. So if negative 4 comes to the back, log to base 10 will cancel out. We're going to be having 3 minus 4. And 3 minus 4, that's negative 1. I'll be having 10 to the negative 4th upon 3 to the power of negative 1. So I will then take the inverse, 1 upon 10 to the negative 4th upon 3. So guys, this is quite interesting. If this flips, we are going to be having, if you take the inverse of this, becomes 10 to the 4th. If you take the inverse of 3, that becomes, no, it's actually, okay. This fraction will flip. I think this fraction will flip. It becomes 3 times 10 to the 4th. So this is also a valid solution. So guys, we've come to the end of this interesting tutorial. Please ensure you give this video a thumbs up, share with your learning friends and colleagues, and most importantly, make sure you subscribe to join this community, and don't forget to turn on the post notification so that you wouldn't miss out in our next videos. See you next time, and God bless.